we want to touch on network analysis. Network analysis. What is a network? What is a network? Christian, what is a
basically network? How things connect, or the connection between.
Yes, exactly. Okay. So your network, you know, people use that in business a lot. My network, you know, I have a lot of network, I can connect you. So it's all about connections, isn't it? Okay.
Yes, sir.
One of the fundamental things we've already learned before we touch on network is topology. And in topology, remember there was a connectivity rule under topology, which said that arcs only join at nodes. And I was telling you guys that we can actually model what happens at a typical interchange, like the Pokwasi interchange or the circle interchange or any popular interchange that we want to talk about. Are you okay? Anywhere in Ghana. Are you okay? So that connection between, you know, one road segment and the other also applies to other areas in life. We can look at pipe network. I think I talked about all that. So whilst we were actually dealing with the subject of topology, I was also introducing the concept of networks. Are you okay? And as you said, it's about connection, connectivity. That is what networks are all about. Are you okay? All right, so you can see examples on your screen. We have road networks. Okay, so in a road network, you can see the connections. Without the connections, you see all the stress we are going through for the past, I don't know how many weeks now. The traffic is all because there's something wrong with the network, and not because Ghana has become very big. Okay, now we are now, it's also part, Accra is so populated, honestly speaking. I think the population of Accra is really, of course, the highest in Ghana at the moment. So if we don't understand networks, okay, and we don't do network analysis, we have such challenges. And then we always, you know, killing ourselves, and the quality of life becomes so bad. I'm getting emotional here. Railway lines, the kind of rails we have in Ghana, they are not rail lines. They are just some metals running on the ground. Are you okay? They are not rail lines. You have to travel.
They are doing a reconstruction.
They are what?
They are doing new ones, so possibly that one will be railway.
Yes, I hear there's a speed train coming up at Tamale.
Hey,
I'm waiting for it. I can't wait to go to Tamale on my speed train. Yeah.
10 minutes to Tamale.
Exactly. It will be fun. It will be fun. Honestly, this is like, let's keep dreaming. Is that okay? Let's keep dreaming. Yeah. But then you shouldn't dream forever. Yeah.
Dreaming in Ghana.
What in Ghana?
Dreaming in Ghana.
Yeah, I can't hear that word very well, but
I'm asking, you are dreaming in Ghana.
Yeah, but that's all we do, isn't
that
it?
That you get the speed train.
Yeah, so or you think it's a reality? How soon are we getting it?
Oh, as soon as possible, when the lines are done.
Not now. Maybe your grandchildren. Maybe your grandchildren will come with me.
Oh, okay. I think we are doing politics now. Let's run away from it. I know which party you belong to. Anyway, so railways, I just want to say that we can have a network, are you okay, of rail lines. Okay. So what you are seeing now on your screen is the London Underground, okay? A part of it. Please, this is not a complete thing. It's a part of it. So think about it. And this is not a surface rail. In Ghana, we are even dreaming about surface rail. Are you okay? Surface trains. This is underground. You can't see it. All this is underground, like rats are moving underground. This is where they are. Of course, we are not developed, but we are always playing that game. You know, we are black and poor, we are Africans and poor, and it's like that mediocrity is always coming into play. But obviously, when you have a proper real network, you will now see the connection and the relation between a real network and a road network. Are you okay? So when you look at this closely, you see that it's just like road network, like there are junctions, isn't it? All right. So there's a place in the UK, there's a place in London called Clapham Junction. Anybody here who has traveled there knows that what I'm saying is true. And that place, Clapham Junction, is a place where a lot of trains are meeting and that. I mean, oh my God. In your dream, if you haven't traveled before, okay, you can dream about it tonight, okay? But obviously, that is what
I've been to a lot of countries. Keep quiet.
Oh, okay. Who is that? Who has been to a lot of countries?
Gotthold has seen it before.
Gotthold, are you there? Gotthold.
My latest country was Togo. And my latest was Togo.
Togo.
Yeah.
Okay. Not bad. Togo is not bad. I haven't been to Togo before, so maybe there's a lot of, rail and all that. How are their rail system like? How many rail lines do they have? Okay, I think it's gone off. All right, but the bottom line is that there's a commonality. All of you start figuring out what is common between the networks. Cables, cable network. We can even talk about wireless network.
Wireless network.
Pipeline network. Are you okay?
Real.
In fact, I'm sitting here at this is the second floor of AIT Sea View. I'm looking at the sea sometimes. At the moment, I'm looking at the Wager Lake, part of it is showing. And I'm seeing, a built-up area with no road networks, proper networks going through them. But it looks beautiful though. It looks beautiful, but it's a sad situation we have here. Pipe, I doubt if there are proper pipe networks going on there. I don't know. I may be wrong. Please correct me. Streams, you can have, there are so many. When it show you like all the rivers and in Ghana, okay, on a map, you'll be surprised. There's so many of them, so many. But there's a popular one going through Kwame Nkrumah Circle. They call it Odona, okay. Odor River is that how it's called? And then it smells very good, okay. And it flows very well. Okay, anyway, yeah, we have even glaciers. Like it depends on how you look at it, but let's leave that. Let's keep that now. So what is common with networks is that we have a resource that is being transferred or being moved along line segments. So as an engineer, this is how you look at it. So you don't get emotional as an engineer. You don't always start, getting emotional about things. You look at the science of it, the mathematics of it. Every network allows you to move something. So in the pipe network, we are moving water. In the road network, we are moving, the car is moving on it. Are you okay? And then whatever is in the car is moving along with it. Are you okay? You can have communication networks carrying packets. You talk an IT guy, a network engineer, and talk about packets. You talk about packets like as if you wouldn't have a clue what he's talking about. Are you okay? That's packets of data. They move from point to point. Okay. All right. So network analysis is like key drainage network. Don't go there. So a lot of stinking areas are simply because we don't have good drainage network. And once there's no good drainage networks, you're going to have stagnant, what is not moving, right? So once it's not moving, what are you going to have? Stagnant, and it's going to stink. All right. So this is our situation. Is that okay? This is our situation. We can have gas pipe networks. Right? So like guys, you have pipes with gas going through them, and we need to look at that. We can have low voltage, high voltage electrical networks, okay, where ECG knows exactly where they turn in the light off. Because there's a part of Ghana they never experienced doing so before. Are you with me? And it's not their fault because ECG doesn't know that they are there. Okay, they don't know they are there because they don't have
oil,
system.
gas,
okay. Oil, exactly. We can have oil pipe networks as well. Right, but the interesting about network analysis is what we see when we watch a movie, and then someone is sitting behind a computer and they are telling you what is happening at certain places and certain points within a building, within a city space. Are you okay? And what is interesting about it is that you're able to manage it. If you can't manage a network, in fact, I mean, look at the pathetic situation of the traffic at Jowulu and everywhere now. Everywhere you go, there's traffic. I'm so not happy. I'm so not happy. Everywhere there's traffic. There should be a reason to have traffic. Are you okay? So that one is the road network. Why? Because it's not been modeled. Nobody's doing road network analysis in Ghana at the moment. We are living in some, I don't know which age we are living in. Okay, but there are requirements for a network to work. And that is what I think is a problem with us. That for every network, you need to have accurate data. It has to be updated. So you need to be collecting data, making sure you have up-to-date data. It should be compact, it should be like well-structured. Topologically, it has to be correct. So you have connections where you're supposed to have the connections. So if there's pipe flowing from one conduit to another, the model should have that representation so that it can tell you that it's blocked or it's not, things like that. Okay, so when we take a road, civil engineers, of course, civil engineering goes beyond just roads, but obviously roads are so common. We can talk about attributes that need to be incorporated into your road network data set, which will make it beneficial. So for such a system, the road conditions should be captured, classification of the road should be captured. We want to have a system that makes use of the road, a network analysis. Then the speed restrictions, one-way streets, turning restrictions, all these are attributes or characteristics of a road segment, are you okay, or junction. Sharp junctions, road runabouts, all these things have to be captured in there. Okay, so network analysis is the main thing, but like all things being equal, if you've collected your data and then you have it up to date and accurate, then you can start thinking about some of the things that can be done on a network. Are you okay? A network can be defined as a set of linear features through which resources flow. I don't need to even talk about this, but I expect you, when I ask you to produce this for me, okay? Nodes are used as origins and destinations. Resource. A resource needs to move from one node, one junction, a source to a destination. Are you okay? So nodes that we mentioned in topology are appearing again. So remember that connection, all right? Nodes can have properties, but in network analysis, we are usually more concerned with the characteristics of the links as well. Are you okay? So the junction, there's a lot that can happen in a junction, but a junction is really a place where we are connecting a couple of arcs or lines, okay? All right. All right, see you then. Yeah, so network analysis, we can actually look at a classification of networks. We can have unoriented networks that are not oriented, no direction. We have, networks which are oriented networks, unoriented networks which are looped. There are networks which are not looped. Are you okay? They go in just one direction. You don't come back. Let me put it that way. So we can have the loops, or maybe it's not characterized with a lot of loops in that case. So we can have oriented with loops, one-way streets, for example, give us an indication of what that classification is about, okay? Network analysis, yeah, I think we touched on this already. Rivers flow in one direction. I hope you are aware. Rivers don't flow in two directions. Are you okay? Do rivers flow and then come back to where they were? No. Are you okay? All rivers seem to be flowing in a certain direction from the source to the destination. So that is where the classification of networks, actually come in. One-way streets are oriented. Are you okay? All right. So let's keep on. Let's talk about algorithms for network operations. Algorithms. What is an algorithm? An algorithm is a set of instructions written in such a way that it can be executed on a machine, on a computer, okay? At the heart of network analysis is a search procedure. So what we see mostly when we watch a movie, okay, is that there's always a search for something, an object, someone, are you okay? a fugitive. Are you with me? Okay. So at the heart of the network analysis is a search procedure. You are always trying to find out, how do I get this object from here to there? It's fundamental. Are you okay? Now, within your network, and remember your network is simply made up of links. The beginning of the link is a node, the end of it is a node. And then the links are connecting each other. That's all. And then the object, the resource, is being transferred from along it, from all sort of possible places, nodes. Okay. All right. So we can decide that we want to select, let the computer select links that take you as far away from the start node as possible. Are you okay? In the case of if you're trying to escape maybe security operations, okay, give me a route. In this route, I want to just move in one direction away, but I don't want to ever look back. Because sometimes you see, you can be given a shortest path that goes and seems to point back where you started from. You know, if you live in Kumasi before and you're coming to Accra, you'll be shocked. The direction you go is not really towards the south. If you've actually lived in Kumasi before and you've been thinking about the direction that the bus moves as it comes to Accra, you realize that it's not going south. Meanwhile, when you look at the map, moving from Kumasi to Accra is going southwards. Are you okay? All right. So you can choose, if you had options of moving from Kumasi to Accra, not to use the current route. And for some reason, I asked myself, why did they choose that? But anyway, so you can do that in the network analysis. These are like, let me just say, the reasons why we do the network analysis. Alternatively, you can search all links that propagate from a node, moving out one link at a time, and gradually accumulate the cost of travel in all directions. So we can actually begin to add the costs. Okay. It takes me 2 minutes to travel from this point to this point. Okay, add it on. How much does it cost to travel from link to link as you go? And in moving from Accra to Kumasi, you can spend all your time at Pokwasi. You know, there was a time where you could spend like 3 hours. Like, you just there. Someone traveling to UK would have reached Algeria. Are you okay? He's rich Algeria. He's so close to the UK. Or going to America. Are you with me? So, yes, network analysis. Hey, as a country, a poor country, you need to do this. What are you waiting for? I'm sure the Indians have already used these things, you know, and it's easy to implement. What are we waiting for? Are you okay? So one can also seek to find a route that passes through the fewest number of nodes. Okay, so here we are talking about America or maybe Germany. I hear they have what they call the freeway or so. You can travel on it like for miles, no junction, nothing, just keep going. Are you with me? So we need to harness the power in knowledge. We need to harness the power in knowledge. Okay? So a common algorithm procedure that is used is what we call the distress algorithm. The distress algorithm. Please, I'll call you back. So Dijkstra, it sounds like a Russian name. You know, they like studying, isn't it? Like hard things. But Dijkstra, what is it about? So we are ending the lecture on this. So everyone, just get ready. We are landing on our lecture on this. To be continued. Maybe I'll touch on this a bit. Then we, in the next lecture, we continue from there. So you can go and read about network analysis. If you find it interesting, go and Google it. It's fun. I think it's one of the most interesting things. What is the shortest path? So the distress algorithm is a shortest path algorithm. The distress algorithm is a shortest path algorithm, which is what we are all using on our phones, Google Map, you say, or Uber is using it. Are you okay? All right. So you want to find out what is the shortest route between this point and that point. Are you okay? Then you get alternate routes based on, okay, sometimes they give you alternate routes. Instead of using this route, use another one. But we are here to find out how distress algorithm works. So distress algorithm works is very simple. But when I ask you an exam, don't go and Google distress algorithm and bring me some other version of it. Please, it's a free advice I'm giving to you. Is that okay? Because There are also things on the web. Okay, so in this transfer algorithm, I want to move from A to J. I want to move from what? A to J, point A to point J. Okay, so what is the cost of moving from A to C? Is 2. Okay, what is the cost of moving from A to B? Is 3. So the computer, initially it is stupid. Let me put it that way. I'm not using the right word for lack of a better word. Let me just say that the computer is just dumb. It's not, it's what you are telling it that it does. So it's searching for a shortest route. So initially, what if you were a computer, what would you think? Would you go through A to C or A to B?
A to C.
Go to A to C. You use A to C. So it will choose A to C initially. Then it will start accumulating the cost. So it will now add 4 to it. It will get 6. 4 to 2 plus 4 is 6. And it will now add 3 and 3, as if it's trying to use the ABE routes. Then it will get 6. Then it will now say, okay, then it means it's about the same, cost about it. That's when it gets to know that it costs about the same amount to travel towards using two links. Then it considers A, C, D. Then it gets 3. Then it actually drops the ACF route and then the ABE route, and then it now adapts the ACD route because it's cheaper. That will give you 3. Are you okay? All right. Then it keeps on adding on. So it moves links. So it takes 2 links, 3 links, accumulates the cost and find the minimum. Are you okay? And so as the algorithm moves, it then selects the links based on the one that is cheaper. Are you okay? Accumulating. Are you okay? So as it goes, as you can see, it's just choosing this link, colored green, and then it considers more links, and then colors green as it goes. Okay, the links that are cheaper, as you can see, is considering these 2, and then adds onto it. Are you okay? It's not rocket science. It's just saying yes and no. Should I take it or I shouldn't take it? In fact, you can write this program. You can easily do it yourself. If you are good at programming, you can easily do this. So you can have the accumulated costs, keep adding on until you find the one which is cheaper. So before we started, you wouldn't have guessed that this would be the cheapest, but that is what is the cheapest: A through C through J, ACG. Okay, and then that becomes the shortest route, and you can work your way backwards. In fact, I found out that moving from Kaswa to Medina doesn't cost you the same amount. Okay, always try that. Moving down the slope and going up the slope aren't the same. All right. So on the same link, you have to do a cost back link. All right. So guys, to be continued, I'll talk more about network analysis, and then I'll introduce probably another topic the next time we meet. So if you have a question, you can ask. Otherwise, I think we even have 60 seconds. So I prefer you don't ask a question. you can defer it to next week. Yeah. So thank you so much for your time.
2 weeks.
And save your questions for next week when we meet, God willing. Yeah. Take care and have a lovely week. I wish you the best in your midterm as it comes up. Yeah.
Hello, sir.
Yes.
These slides.
Say that again.
The one with please, are you sending out this slide?
Yes, I'll send it to you.
Okay,
And the video.
And the video.
I'll get your video as well. So I think the recording, I have to pause I have to stop the recording.